Hello everyone, my name is Nael, I'm a computational journalist and the creator of Code Like a Journalist, a free online open source course about data analysis and data visualization with TypeScript. Today's lesson is about data types. I'm going to do it with you. So, first, on the lessons page, we have a reminder. If you want to know when new lessons are available, subscribe to the newsletter. You can add a star to the GitHub repository. And of course, you can subscribe to this YouTube channel. So I'm going to split my screen. The first thing that we're going to do is to create a new project. So let's open VS Code. Here we go. Here we go. Nice. And you can create a folder anywhere you want on your computer and then open it with VS Code. So I can, here we go, open folder. I have my test folder on my desktop. Here we go. And I'm going to make this a little bit bigger for you. Here we go. So we can create a first file code called main.ts. And inside we can add console log hello. Go. And we can create a dino.json file. This will stay empty, but it will tell VS Code, hey, this is a Dino project. And it will enable the Dino extension. Now we can toggle the terminal and we can run this here. Dino run watch check main.ts. So it's running main, and every time we will save it, it will rerun it, which is very convenient. All right, we're ready. So the first data type on the lesson, strings. So strings is text. And the reason why it's called strings is just because it's a string of character. That's it. In TypeScript, strings are wrapped with quotes. You can use different quotes. So for example, text1 is with double quotes. That works. Here, you can do single quotes as well. But if you save your file, Dino will reformat it, and very often the single quotes will be replaced by double quotes. You can also use backticks like this. It might take a while for you to find it on your keyboard, but they are very useful. We will be using them a lot in the next lessons. So this is a string as well. One reason why backticks are useful is that you can use them to create multi-line strings. So here, for example, we have a console log text1, but if I do console log text4 and save, you can see that I have this string being logged this way with all of the lines preserved. So that's about it for strings. Now, if you want to check if something is a string, of course, you can always hover over the variable. You'll either see a string or you'll see the type string like this. So that's how you can do it on your terminal. Otherwise, you can use typeof. So if I do name, Nail Shiab, so this is the example over here, I can do console log, and then I can do type of name. So when I do this here and I save, I'm telling Dino, hey, grab name, check its type, and let me know what it is by logging it into the terminal. And you see that the type is string. That's it about strings. Numbers. So numbers, you don't need to wrap them in your terminal. You don't need to do that. There is different ways to write them too. So of course you can just write the number like this. You can use an underscore as a separator. So sometimes it's very convenient when you have a big number and you want to have a 1,000 separator to have a better idea of how big it is. So you can use that. So number 1 is being logged over here. You can see that with the underscore, it's being logged the same way. And in TypeScript, you can also use the scientific notation if you are comfortable with it. So that's how you write numbers, well, integers. You can also write, of course, positive and negative numbers, right? So this is a positive integer. This is a negative integer with the minus sign in front of it. And you can also, of course, do decimal numbers with the dot syntax, and of course, negative decimals. There are a few special numbers. For example, infinity, positive infinity, negative infinity. You can see logged here. Sometimes they are useful. There's also like a maximum value number that TypeScript is able to log. So if you go above that, you will see infinity, or below that, you'll see a minus infinity, but it's pretty rare. But know that it can happen. Oh, and by the way, here I'm showing you a different way of logging things. So instead of writing something like this, here, so using 2 console log statements, if you want to log multiple things at once, you can separate them with a comma, like this. Another special number is nan, which stands for so nan like this, which stands for not a number in Camo case, almost Camo case. I don't know why the first N is capitalized here. Anyway, so nan, not a number. Sometimes when you have, this is a great example. So for example, let's say that you have this string here, this text, 42. It's text because it's quoted, it's wrapped with quotes. So it's really the text 42, it's not the number. But let's say that you would like to convert it to a number. You can use parseInt, which is a global function that is always available for you. We'll talk more about functions later on. The important thing is to remember that this here can grab text and convert it to a number. It will try to convert it to a number. Here, this will work. 42 can be converted to an integer. So you'll see in the console log here, 42. But the second example here, we are trying to parse as an integer something that is not a number. Hello cannot be converted to a number. So parseInt parseInt will return nan, not a number. I'm not able to parse this as a number. Right? So this is a special value for a number. Sometimes it will happen. And yeah. If you want to check if something is a number, you can, of course, hover over the variable when it's being used. So here decimal is 10.5. If you use let, it will become a number, right? Type number. But something you can do as well is use type of with the variable. And exactly like we did with strings, you'll see that in integer, 1000, the type of this is number. A type of a decimal, 10.5, type of will be number. Infinity is a number, and not a number is also a number, which can be weird, but that's the way it is. Let's talk about booleans now. So if you're not familiar with code, booleans might sound very weird at first, but they're very simple. A boolean is a value true or false. That's it. That's the only thing about booleans. And they are very, very useful when you work with conditions. If this is true, do that. If this is false, do this. We'll see that in a later lesson. So in the example that I'm showing you here, you can see that boolean 1 is true, and you can see it's being logged over there, while boolean 2 is false over here. And when you compare things, you can have something that is true or false. So for example, here we have a comparison, 3 greater than 2. Is that true or is this false? You'll see that comparison is a boolean. We are comparing 3 with 2. And there's just two options here, two outcomes. Is it true or is it false? We are logging the comparison after that, and you can see that is 3 greater than 2? True. This is true. We can do also smaller, and now the answer is false. Booleans. Again, if you want to check if something is a boolean, you can use the type of keyword. So you can see that true here, its type is boolean, and false, its type is boolean as well. So we saw strings, numbers, and booleans. Now let's talk about dates. So we will be using dates a lot in data analysis. Dates are not a type per se. It's actually a class in TypeScript. And the way dates are represented is by the number of milliseconds elapsed since January 1st, 1970 UTC. So that's how it works. And I'm going to show you an example. So for example, if we want to know the date right now, we can do console log date now. And you see we have the number of milliseconds since January 1st, 1970. That's how it works. Date now returns the number of milliseconds, but we can also create a date with new date, and you can see that this is the current date right now. There's other ways to create dates, but it's always kind of the same way. We have new date and we pass parameters to this. We'll talk more about parameters in another lesson, but basically if you create a new date like this without anything between the parentheses, you are creating a date representing right now, well, right at the time of creation for this variable. If you specify a number of milliseconds, it will be the number of milliseconds. So if you pass in 1000, it's 1000 milliseconds, which is 1 second after January 1st, 1970. All right, so you can see it here, 1 second. You can also pass a standardized date string. So the year, the month, the day, T stands for time, which comes right after, the hours, the seconds, the minutes, the seconds. You can also add the milliseconds if you want. And Z just means, hey, it's UTC time. It's not my time zone, it's UTC. And you can see that here. So for example, this is Christmas morning at 8 a.m. And you can also throw weird things in there and it will create an invalid date, which is still a date, but just invalid. So, hi, I'm not a date will become invalid date. If you want to check if something is a date, you cannot use type of, because type of checks the type. And if we do it, you see that we are creating a new date here, current time. We're using type of current time, and it returns an object, not a date. So instead, what you need to do is to use, instance of. So current time, is it an instance of a date? And the answer is true. This is how you check if something is a date or not. Of course, you can also hover over the variable and you'll have the information right away. There's other data types that you will often encounter in TypeScript, undefined and null. So let's check them. So if you create a variable without assigning a value to it, it will be undefined. So for example, here we are creating a let variable something, but we're not putting anything in it. So something here will be undefined. By the way, if you try to do that with const, you'll get an error because constant variables must be initialized. You need to put something in it. But with let, you don't have to. If you use const, you can also put an undefined inside a variable. A little bit weird. I don't know why you would do that, because this would stay undefined forever. So basically you won't be able to do anything with it. But yeah, you can if you want. So it's being logged over here. And if you want to explicitly assign a variable with no value, you can use null like this. Right. Here, it's not very interesting to do anything like that, but sometimes when you work with data sets, you'll see that some values are null. Sometimes it's because you want them to be null. Now, to check if something is undefined or null, you can use the strict equality operator. So you see here we're creating a new let variable. We're putting nothing in it, so it's undefined. To check if it's actually undefined for real, we can call the variable with the triple equal sign and say, hey, is this does this equal this? And the answer is yes, it is. It's undefined. We can do the same thing for null. So right now this variable, it's a null value, and we say, hey, does what's in this variable equals null? Yes. Okay, it's true. That's how it works. Sometimes you'll see 2 equal signs instead of 3. It's not doing exactly the same thing. It's best to use 3 to have a strict equality being checked. Now, depending on the data type, you have different properties and methods available. We will talk about it more later on, but I just wanted to touch on it. So for example, in this example here, this sentence, where is Brian? We have a string, and strings have a property length, which is the number of characters in it. If you start typing sentence and you put a dot right after it, you have all kind of things available. Some of them are properties, some of them are variables, not variables, methods. You have all kind of things, and you can see that length is over here. And if we save this, you'll see that we have 15 being logged right now. It's the number of characters in Where is Brian? By the way, this is one of the first, very first sentence that French people learn at school when they are in English classes. Where is Brian? So you have a lot of properties available depending on what you're working on, and also methods. So for example, since it's a string, we have access to a method called toUpperCase. You know it's a method because you have the parentheses here. It's triggering a change. It's putting everything all caps. So properties and methods. We are going to have another lesson just about that. Yeah, I can show you another example. So if we do const value equals 2, for example, now value is a number. And if you do a dot, you'll see that you'll have different methods and properties available because value now is a number. It's not a string. And you can do stuff with numbers that you can't with strings. All right, and that's the end of the lesson. So we talked about strings, numbers, dates, booleans. We are going to use them all the time. There's other types like big integer, objects, functions, but we are going to work with them later on. If you want to know when new lessons are available, check the newsletter, the GitHub repository. Ping me if you have any questions. The next lesson will be about data structures.